You have you have y equals 2 to the x here. I don't actually need all those points, but we have y equals 2 to the x there, and you have y equals log base 2 of x here. As I make the base bigger, remember what happens to the exponential graph? Those points are nothing now, but it gets steeper. The exponential graph gets steeper. This corner gets sharper as well here, right? This corner, this goes quickly more vertical like this. This is going to turn the corner like that. If you make this lower and lower, if you make it almost, 1, even less than 2 here, it's going to be hardly going up to the right at all. And this is going to be hardly turning the corner at all. If you make it negative now, or not negative, if you make it less than 1, this is the one that people are having, this is the one that people have a harder time with, because this goes down to the right, that exponential graph. This kind of goes down to the right as well. It's got a vertical asymptote instead of a horizontal asymptote. Right? There are always reflections over that point in the middle. If it's less than 1, like if it's between 0 and 1, the exponential graph goes down to the right, and so does this graph. If the base is bigger than 1, it goes up to the right, and then that one kind of goes up to the right. What happens when I make the base equal to 1? Look at the two of them, okay? What do you expect is going to happen here? What's going to happen with this one? What's that going to be? That's going to be a horizontal line. What's this going to be? Are you sure?
Yes. I don't know now.
Now that I said that? Where is it?
Undefined.
It's undefined. This is actually undefined. You can't have a logarithm with a base of 1. You can't have a logarithm with a base of 1 because it's the inverse of a horizontal line. The base of a logarithm, you hopefully are going to know now, can't be 1. What else can it be here? What happened there? Where is it? The exponential graph has kind of degenerated onto the axis there. 0 to the x, we looked at that before. 0 to the x is over there. The logarithm graph has also totally disappeared. You can't have a base of 0 and you can't have a base of negative. The base of a logarithm graph can't be negative, can't be 0. So essentially it has to be positive, but there's one exception. It has to be a positive number other than 1. The base of a logarithm can't be 1 because it would be this vertical line here. That's not a function. So as you're going through and looking at this, understand what you have to do. You have to think about, in general, what the inverse is. This is review from grade 11, or should be. Inverse of an exponential function. We've talked about this, but you need to get it down on paper and plot some points and things and solidify it in your mind. Look at what happens with various bases for logarithm graphs. They're the inverses. Think of the table being reversed. Think about the questions as you go through, and then we're looking at transformations. Think about transformations of this. One other thing to note here was when we had y equals log base 2 of x. When we had log base 2 of x, it looked something like that, right? What's the domain of that thing? What values is x allowed to be there? What values is x allowed to be? Positive numbers, right? No, the base can't be, if we make this the variable, when I was changing that number, I was changing the base. Okay, so that's kind of important to know here. This number, if you look at the domain of the graph, it's all the values here, right? There would be an empty circle there. It's all the positive numbers. The graph doesn't continue on to the left side. For a logarithm graph, the domain has a restriction, but the range could be anything. Any number on the y-axis is possible. For an exponential graph, y equals 2 to the x, it looks like this, right? It's going up like that. For this one, the domain can be anything, but the range is restricted. It's from there up. It only covers, you can't have negative numbers for that as the y values. For this one, the y values can't be negative. For this one, the x values can't be negative. Or in other words, they have to be positive. So make that connection in your mind that For a logarithm graph, the domain is restricted. For an exponential graph, the range is restricted. The thing I was talking about the base was if we said this, log base b of x, b has to be greater than 0 and b cannot be equal to 1. This is important to know there. The base can't be negative, it has to be positive other than 1. I think I have that in here somewhere, right? But can't remember. Restrictions on the base. There is a thing that asks you to look at that. So it's not that from what we just talked about in the last 15 minutes is you need to understand it completely. You need to work through this, okay? You got some time right now to get some stuff done. My goal would be that you would be able to get through it more quickly, having gone through it together. Can you work on that, please? Any questions? Ask away while you're working. I'm hoping you understand up to the end of 2.8 by the time you come in next time. Make sure you use your time, guys. Get going on something right now. What's up? What I would do is think about what points are on y equals 2 to the x and switch them. Like for 2 to the x, like 1, 2, 2, 4, 3, 8. So 8, 3 is going to be on this, and 4, 2, and 2, 1. Like just switch the x and the y for the inverse. If you're trying to graph a logarithmic function, oh, this is good. I'm still recording. So I don't need to say it again. I can pause this though.